This is David Spears, Civil Engineering Instructor at Texas Tech University, talking about statics, CE 2301. Got another 2D rigid body equilibrium problem for you. And once again, whenever you see those words, I want you to remember those three steps, which are do a free body diagram, get everything in Cartesians, and do sum of moments, equilibrium, sum of moments, and sum of forces equals to 0. So, in this problem, I just want to know the reactions at A and D. This is a truss, but I'm not going to try to solve for member forces. I just want the reactions at A and D, which are, at A I have a pin, and at D I have a roller. So, don't let the fact that it's a truss bother you. It's just still a rigid body. It's one rigid body that's in equilibrium. So these equations have to hold. So the first step is to draw a free body diagram. And so I just want to look at this thing as a big trapezoid that looks something like this, and ignore all the stuff, all these bars and stuff going on in here. Just treat it as a trapezoidal shaped rigid body and put the forces on it, solve for the reactions. So I've got 4 kips to the left up here. I've got a reaction at A. At A I've got a pin, so I have X and Y reactions. A Y I assume up, A X I assume to the right. At D I have a roller. It allows movement to the X direction horizontally, so all I have at D is a Y reaction. Then I put my loads acting down here on the bottom, 2 and 1. 2 kips, 1 kip. Make a little note to myself, my dimensions are 5 feet in the vertical and 5 foot bays, or 5, 5, and 5. There I've got a beautiful free body diagram that tells me everything I need to know to solve it. Everything is in X and Y, so I don't need to worry about geometry or getting everything in Cartesians. I've just kind of done that as I drew the free body diagram. Therefore, I'm ready to move to step 3, which is to sum moments about a point to eliminate unknowns. So I can choose either point, and let's sum moments about point A to eliminate AX and AY. So I've got an equation that looks like this. Sum of moments about point A, as I always do. So generally, that was not what I wanted to do. Assume counterclockwise is positive, that's 0, the sum of the moments. And starting off on the left end, I've got AX and AY both intersecting the point. So there's 0, they create no moment because they intersect the point. Moving to the right, I have this 2 kip load, which I hope you can see causes clockwise rotation, so it's -2 times a distance of 5 feet. It's a Y force times the X distance. The 1 kip load also tries to create clockwise rotation. So it's -1 times 5 plus 5. I have dy trying to rotate in the opposite direction, in the counterclockwise direction, so it's positive dy times 5 plus 5 plus 5, or 15 feet. 5 plus 5, there is 10. And then sloping down, I still got every straight line force on a rigid body creates some moment, unless it intersects it like the ones at A. So I've got to consider this 4 kip load up here. if you're still having trouble seeing direction of rotation, the principle of transmissibility means I can move this force over here so it's directly above point A. There you can see pretty easily it's just creating counterclockwise rotation about point A. So it's positive 4 kips. It's an X force, a Y dimension is 5. And I've got every force accounted for. So ready to do the math. Negative 2 times 5 is negative 10. Negative 1 times 10 is negative 10. Positive dy times 15. And 4 times 5 is 20, positive. So I do the math continuing, and I get negative 10, and positive 20 gives me 0 plus dy times 15 equals 0. Therefore, dy equals 0. Well, this kind of perplexes me. Didn't expect that. So, another way I can check these things is by summing moments about some other point. So in this case, I can sum moments about D and check my answer. So, let's do that real quickly. Sum of the moments about D is also going to be 0. And now I'm summing moments about here, so let me do this in a different color so it looks different. So, starting off over here, AX passes through point D, so it has no Y distance, so it creates no moment. But AY is assumed up, so it's going to create clockwise rotation, so that's going to be a negative AY times this distance of 5 plus 5 plus 5, or 15. Then I got 2 kips trying to rotate. Now I'm rotating about D, remember? That's going to try to create counterclockwise rotation, so it's going to be plus 2 times 5 plus 5, for 10. Then I've got 1 kip trying to also create counterclockwise rotation, so it's plus 1 times 5. And I've still got this 4 kips to deal with. It's trying to rotate counterclockwise about point D. So I've got plus 4 times its Y distance of 5. So I've accounted for all my straight line forces, multiplied them by their distances. Do the math. I've got negative AY times 15 plus 2 times 10 is 20, plus 1 times 5 is 5, plus 4 times 5 is 20. Combine those, I got negative AY times 15 plus 45 is equal to 0. Take the negative AY 15 over to the other side of the equal sign, and I've got positive AY is equal to 45 divided by 15 equals 3 kips up. The positive means my sign assumption of up, direction assumption, was correct. Report my answer like that. Now I'm going to do sum of forces in the Y direction and check my answer. I assume positive up equals 0. So now I've got AY as 3. That's AY. Then I've got minus 2, minus 1. And I figured up here that dy is 0 plus 0. That's dy, so that all should equal to 0. 3 minus 2 minus 1 is 0, so sure enough that checks out. I could have done that first and solved for AY as 3 and checked it with that moment calculation. I just was curious because I got an interesting answer, a zero answer. So I just use sum of moments. So you can oftentimes check your answers using a different sum and moments about a different point. So finally I need to do sum of forces in the x direction. It's equal to 0, positive to the right. I've got AX up here, assume positive to the right. And then I have minus 4 kips up there on the top at point C. So therefore AX, and that's all I have in the x direction, is equal to 4 kips. The positive number means my direction assumption was correct. So there's my 3 answers. Some of these are really easy. You can look at them and just see what they are. The only thing I have in the x direction is this 4 kips to the left. So AX has got to be equal to 4 kips. So I can just kind of don't even have to do calculations for that one. So there you see that. The thing is, all the problems in this class are going to be rigid bodies. And so I can get reactions by just creating them, thinking of them as a blob or just a solid rigid body that doesn't deform.